Tonight, we drift into one of the quietest wonders of the universe, the nature of light, and the calm, constant speed at which it travels. As you settle in, imagine the gentle stillness of space stretching out in every direction, vast, silent, and timeless. In this darkness, light moves softly, carrying with it a sense of clarity and peace. This is science for sleep, a quiet place to unwind, rest, and drift through the softest corners of the universe at your own pace. The speed of light is often described as astonishing, but in moments like this, it feels more like a steady, reassuring presence, something that simply is, unchanging and serene. It is the quiet rhythm the cosmos follows, the pace at which galaxies reveal their glow, and the soft measure of time across great distances. As you listen, let the ideas come to you slowly, the way starlight crosses the emptiness between worlds. There is no need to focus or hold on to anything. Just allow each thought to drift by, gentle and effortless. Picture a single beam of light leaving a distant star. It glides without hurry, moving the same way it always has, passing through regions of space that no eye has ever seen. For millions of years, that faint shimmer travels forward, patient, calm, and unwavering, until finally, it reaches a place where someone is awake, listening, slowly drifting into rest. Light moves too quickly for us to truly perceive, yet the story it tells unfolds at the perfect pace for quiet reflection. Every ray that touches Earth has traveled across unimaginable distances, carrying whispers from ancient moments long before we were here to notice. Tonight, we follow those whispers, not to learn or analyze, but simply to experience the calm that comes from understanding something vast and steady, something that gently reminds us that the universe has its own natural flow, smooth, silent, and consistent. Let your breathing soften. Let your thoughts loosen their edges. Let the calm rhythm of light guide you into a deeper stillness. As we begin this quiet journey, we'll explore the softest, most relaxing ideas about the speed of light, how it moves, what it reveals, and why its presence is woven so gently into the structure of everything we know. And with each idea, feel free to drift, to wander, or simply to rest. You're not here to memorize anything, just to enjoy the soft unfolding of a universe that moves at its own peaceful pace. When you're ready, we'll begin. Let the quiet story of light guide you into a calm and restful night. Light moves with a quiet certainty, crossing the universe at a pace so smooth and effortless that it feels less like motion and more like a gentle unfolding. In the emptiness of space, where there is no resistance and no sound, light glides forward at nearly 300,000 kilometers every second. It does not rush. It does not strain. It simply moves with a calm consistency, as though it has always known exactly where it needs to go. Even when described in numbers, its speed feels more like a soft rhythm than a measurement. In the fraction of a heartbeat, light can circle the Earth several times, touching oceans, mountains, and clouds before most thoughts have time to form. Yet despite its incredible pace, its presence is delicate, a quiet shimmer that reaches us without ever disturbing the silence around it. When light leaves the surface of the sun, it begins a peaceful journey across the solar system. It takes a little over 8 minutes for sunlight to reach Earth, gliding over millions of kilometers of open space. During that short stretch of time, it passes drifting dust, the gentle pull of gravity, and the distant paths of planets, all while maintaining the same steady pace. Nothing slows it, nothing speeds it up. It moves the same way it moved billions of years ago. There is something comforting about a speed that never changes, no matter the setting. Light behaves the same whether it is streaming from a star, reflecting off a quiet lake, or glancing softly across the walls of a room at night. Its constancy forms a foundation built into the universe itself. Everything we see, everything we measure, and everything we understand about distance and time relies on this single, unwavering pace. If you could watch light as it travels from a faraway star, you wouldn't see chaos or urgency. You would see a gentle glow drifting outward, spreading calmly into the surrounding darkness. That ray of starlight may continue its journey for thousands or even millions of years before it touches the eyes of someone here on Earth. And when it arrives, it carries with it the quiet memory of a moment long gone. A moment preserved and delivered by the soft patience of light's constant motion. The speed of light is not just a physical limit. It is a quiet rule woven into the structure of reality. According to Einstein's theory of relativity, nothing can move faster than light in a vacuum. Not because the universe restricts it, but because light defines the rhythm by which space and time themselves unfold. Everything that happens, every movement, every change, is measured against this serene universal pace. If you were floating in a spacecraft far from any planet, watching light drift past you, you wouldn't sense its incredible speed. There would be no blur, no streaks, no roar. Instead, you might sense a softness, a smoothness in its presence, a kind of quiet reliability. Light remains steady even in the deepest void, carrying warmth, information, and color across distances so vast that the human mind can barely hold them. You experience a small version of this whenever you look up at the night sky. Every star you see shines with ancient light. Some of it left its source long before humans walked the earth. When that gentle shimmer enters your eyes, it brings with it the soft echo of a time far removed from the present moment. The constancy of light speed allows you to look into the past simply by gazing upward. Even the nearest large galaxy, Andromeda, appears in our sky only because its light began traveling toward us more than 2 million years ago. That soft glow drifting through your field of vision tonight was already in motion before our species existed. It has crossed the void between galaxies with quiet steadiness, following the same rules that guide every beam of light anywhere in the universe. Here on Earth, you see light's constancy in small, familiar ways. When you switch on a lamp, the room brightens instantly, but even this moment follows the same cosmic rule. Light moving at its universal speed, bouncing from wall to wall in gentle reflections until it reaches your eyes. The time it takes is microscopic, almost imperceptible. Yet the process is identical to the journey light takes across interstellar space. The fact that nothing can travel faster than light creates a natural harmony in the universe. If anything could move more quickly, the balance of cause and effect would shift, and time itself would behave differently. Instead, the universe remains calm and predictable, shaped by the steady presence of light's unchanging pace. It is a soft reminder that even in a vast and complex cosmos, there is order, a quiet underlying rule that everything follows. Light also gently shapes what we can see. Beyond a certain distance, the universe becomes faint, not because it disappears, but simply because light has not had enough time to reach us yet. The cosmic horizon expands as light continues its slow reveal, letting us discover distant galaxies only when their ancient glow finally completes its long journey. This gradual unveiling allows the universe to present itself gently, as though revealing its secrets one soft moment at a time. Even the colors we see are shaped by light's movement. Shorter waves, like blue and violet, ripple quickly, bringing crisp, cool tones. Longer waves, like red and orange, move more smoothly, spreading warmth across sunsets and galaxies. As the universe expands, the light from distant galaxies stretches and shifts toward red, creating soft hues that help astronomers understand how far that light has traveled. Each subtle shade is a quiet message written in color. In the equations that describe reality, the speed of light appears again and again, like a calm signature woven through the fabric of the cosmos. It determines how energy moves, how time flows, and how space bends. Light speed is not just a number. It is a gentle guiding rhythm that keeps the universe in balance. As you reflect on these ideas, allow the steadiness of light's journey to bring a sense of calm. Across billions of years and unimaginable distances, its pace has never changed. Every star, every galaxy, every quiet beam of morning sunlight follows this same peaceful rule, reminding you that even in the vastness of space, there are constants that remain beautifully, reassuringly the same. As light travels through space, it moves through a vacuum that offers no resistance, allowing it to maintain its perfect, unwavering pace. This quiet journey continues regardless of distance, regardless of direction. There is no friction to slow it, no medium to disturb it, and no moment where it pauses to rest. It simply flows, as though following a gentle current set into motion at the beginning of time. Even when light interacts with matter, it rarely loses its elegance. It may scatter through dust clouds or reflect off the surfaces of distant worlds, but each interaction is brief, like a soft touch that barely disrupts its path. When light passes through air or water, it slows slightly, not because it grows tired, but because it is being absorbed and re-emitted by atoms along the way. Yet once it returns to empty space, it resumes its familiar, constant speed, as though the universe gently guides it back to its natural rhythm. This ability to move freely through the vacuum makes light a kind of universal messenger. It carries information from one place to another, revealing the positions of stars, the shapes of galaxies, and the subtle structures hidden in the darkness. When astronomers observe distant objects, they are not looking at the present moment. They are looking at light that has traveled across great expanses of time, bringing with it quiet stories of how the universe once looked. Some of the oldest light we can detect comes from the cosmic microwave background, a faint glow that fills the entire sky. This ancient light has been traveling for nearly 14 billion years, ever since the universe first became transparent. It drifts gently across space, stretched into soft microwaves by the expansion of the cosmos. When sensitive instruments detect this faint shimmer, they are capturing the universe's oldest memory, whispered across time at the speed of light. The distances involved in these journeys can be calming to consider. When we speak of a light year, we are describing how far light travels in a single year, a distance so large that it becomes difficult to imagine. Yet at the same time, it feels peaceful, like a long, slow exhale stretching across the cosmos. A star 10 light years away is not distant in any threatening sense. Its light merely travels a bit longer, drifting gently across space until it reaches our world. When light passes near massive objects, such as stars or black holes, space itself curves around them. Light follows these curves, bending its path without ever changing its speed. This phenomenon, known as gravitational lensing, turns gravity into a quiet sculptor that gently guides light's trajectory. Sometimes, this bending creates soft arcs or mirrored images of distant galaxies, as though the universe itself were reflecting a calm and subtle design. Even the idea of light moving through expanding space has a sleepy quality. As the universe grows, the space between galaxies stretches, and the light passing through it stretches as well. Its waves lengthen, shifting towards softer, redder tones. This redshift is not a force acting upon light. It is simply the result of space opening gently, carrying light along with it. The universe expands in silence, and light keeps its steady pace within that silence. On Earth, the speed of light shapes everyday experiences in gentle ways you might not notice. When you see a distant lightning flash, the light arrives almost instantly, while the sound reaches you seconds later. This small delay creates a quiet space between what you see and what you hear, a reminder of the difference between light's soft immediacy and the slower movements of other forms of energy. Even in familiar moments like this, light's consistency remains reassuring. The warmth you feel from sunlight is also part of light's nature. Photons traveling from the sun carry energy across space, and when they reach your skin, they share a small portion of that warmth. Each ray has journeyed across millions of kilometers, untouched and unchanged, gliding through space before gently arriving on Earth. The warmth you feel is the memory of that long, effortless journey. Deep in the universe, light takes part in processes we may never see directly, yet its behavior helps us understand them. When particles collide or atoms release energy, they often produce photons that move outward at the universal speed. These events can be violent or chaotic at their source, but the light they produce quickly becomes smooth and calm, spreading across space with the same steady rhythm as all other light. When you think about the speed of light, it may seem impossibly fast, but from light's own perspective, time barely passes at all. For a photon, the journey from the sun to Earth happens in what feels like no time. Even a billion-year journey from a distant galaxy occurs without any sense of duration. Light experiences the universe as a single, seamless moment, moving through existence with complete ease. This idea that light experiences no time adds to its calming nature. While we measure days, hours, and minutes, light simply moves, unchanged by the passage of time, unaffected by the transitions and moments that define our lives. Its constancy becomes a reminder of something timeless, something beyond the fluctuations of everyday experience. And so, every time you see the gentle shimmer of a star, the warm glow of a lamp, or even the soft reflection of sunlight on water, you are witnessing a process that follows the same rule across the entire universe. Light always moves with purpose, but never with urgency. It reveals the world quietly, guiding your eyes to colors, shapes, and details without ever disturbing the calm around you. As you continue to drift through these ideas, let the steady pace of light create a sense of peace. Across immense distances and ancient stretches of time, it moves the same way it always has, smooth, silent, and unwavering. In this constancy, the universe offers a gentle reassurance that even in the vastness of space, there are rhythms that remain beautifully dependable, waiting patiently to be noticed. As light continues its endless journey, it becomes a quiet bridge between places that may never meet in any other way. The universe is vast, and the distances between stars and galaxies stretch into unimaginable scales. Yet light crosses these expanses without hesitation. Each photon travels alone through the stillness of space, carrying with it the subtle imprint of whatever created it. The warmth of a star, the glow of a nebula, or the energy released in the earliest moments of the universe. When we observe the sky, we are really observing the paths of countless photons that have traveled across time to reach us. Some began their journey recently, from nearby planets reflecting sunlight. Others have traveled for centuries from distant stars, and some have crossed billions of light years, bringing faint traces from galaxies that formed soon after the universe was born. In each case, the speed of light determines how long their journey takes, organizing the cosmos into layers of distance and time. Even within our own galaxy, the scale is calming. The Milky Way is about 100,000 light-years across, which means that if a beam of light were to travel from one end to the other, it would take 100,000 years of quiet, uninterrupted motion to complete its path. This perspective makes everything feel spacious, gentle, and slow, despite light's incredible speed. The universe has room to breathe, and light moves through that space with a rhythm that never changes. When we talk about distances in astronomy, we use light itself as the measuring stick. A light year is not just a number, it's a story of movement, a smooth stretch of time during which light has been gliding through space. When you hear that a star is 10 light years away, it means that the light you see tonight began its journey a decade ago, traveling with unwavering consistency until it reached you in this quiet moment. Some objects in the universe are so distant that we can only see them as they were in the very early stages of cosmic history. Their light has been traveling toward us since the universe was young, drifting across expanding space for billions of years. When we observe these ancient galaxies, we are looking into a past so deep and serene that it feels almost dreamlike. The speed of light allows us to experience this time-traveling effect, revealing the universe not all at once but calmly, layer by layer. As stars age, they emit light in different ways, but their photons always move at the same speed. Young, hot stars glow with bright, energetic light. Older stars emit softer, redder hues. Yet the moment that light leaves their surfaces, the universe treats it all the same, carrying every wavelength forward with the same smooth pace. This equality in motion creates a quiet harmony between the different colors and energies that fill the cosmos. In the calm regions between stars, light travels through the interstellar medium, a sparse mixture of gas and dust spread thinly across space. Even here, where occasional particles may scatter or absorb light, the overall journey remains fluid and uninterrupted. These interactions add subtle textures to starlight, shaping the patterns astronomers use to understand the composition of distant stars and galaxies. Every faint shift in color or brightness is a gentle clue written into light by the nature of its long path. Some of the most soothing aspects of light come from recognizing that its speed places soft boundaries on what we can know. Because light takes time to reach us, the universe reveals itself gradually. We see nearby stars as they were moments ago, distant stars as they were years ago, and faraway galaxies as they were in the earliest eras of cosmic evolution. This creates a gentle layering of time, allowing us to look into the past without ever leaving the present. As light travels through space, its waves may stretch or compress depending on the motion of objects along its path. When distant galaxies move away from us, their light stretches into longer, redder wavelengths. This redshift tells astronomers that the universe is expanding, opening space between galaxies with a soft, continuous motion. Light responds calmly to this expansion, adjusting its wavelength without ever altering its speed. The universe grows and light drifts gracefully within that growth. Even the blue sky above Earth is shaped by the behavior of light. When sunlight enters the atmosphere, shorter blue wavelengths scatter in all directions, giving the sky its gentle hue. Longer wavelengths pass through more easily, contributing to the warm tones of sunrise and sunset. These everyday colors are reminders of how light interacts with its surroundings, bending and scattering in ways that shape our world without ever disturbing its tranquility. In the vacuum of space, where light travels most freely, it becomes a symbol of the universe's quiet order. Photons, the tiny packets of energy that make up light, have no mass. This allows them to move at light speed without multiplied speed without resistance, carried only by the smooth geometry of space-time. Their movement is not forced, but rather a natural expression of the universe's structure, the way reality guides energy from one place to another. The constancy of light speed also sets the ultimate limit on the flow of information. No signal can travel faster than light, which means that the universe has a built-in patience, a calm structure that prevents anything from happening instantaneously across vast distances. This limit creates a sense of continuity, ensuring that events unfold in a gentle, connected sequence rather than in sudden, chaotic leaps. Even when light interacts with matter at the smallest scales, such as in atoms or molecules, it follows the same universal rules. Photons are absorbed and emitted in quantized steps, creating spectral lines that identify the elements and conditions of stars. These interactions are precise, delicate, and beautifully ordered, revealing patterns that remain consistent across the entire universe. Whether in a distant star or a quiet laboratory on Earth, light behaves with the same calm predictability. As you let your thoughts wander through these ideas, you may notice how the nature of light brings a sense of spaciousness to the mind. Its journey is both swift and serene, both immediate and ancient. Every beam of light connects distant moments, drifting through the universe with a smoothness that invites relaxation. In understanding the steady pace of light, we also find a way to slow our own thoughts, settling gently into the quiet rhythms that shape the cosmos. Light's journey grows even more tranquil when you consider how it shapes the boundaries of the observable universe. Because light takes time to travel, there is a horizon beyond which we simply cannot see. Not because nothing exists there, but because the light from those distant regions hasn't had enough time to reach us yet. Space itself may extend far beyond what we can observe, but our view expands only at the pace of light's steady movement. This creates a soft curtain draped around the cosmos, one that slowly pulls back as the ages pass. The observable universe is about 46 billion light-years in every direction, even though the universe is only about 13.5 billion years old. This discrepancy arises because space is expanding even as light travels through it. As the cosmos grows, distant regions move farther away, stretching the paths of light into gentle arcs that lengthen over time. The universe unfolds like a slow cosmic sunrise, revealing more and more of itself through the patient arrival of ancient photons. In the vast darkness of intergalactic space, light often travels without interruption. These enormous voids are sparsely populated, offering only the faintest scattering from occasional particles of dust or rogue atoms. Amid this stillness, light moves in straight, clean paths, unaffected by turbulence or noise. It drifts past galaxies and clusters, carrying silent messages from places that are unimaginably remote. Sometimes, this stillness is broken by the presence of massive structures. Galaxy clusters, containing thousands of galaxies, exert strong gravitational fields that bend the path of passing light. This bending does not alter its speed, but it can create beautiful distortions, arcs, rings, and mirrored patterns that reveal the presence of mass through the soft curvature of space. These gravitational lenses act like cosmic magnifying glasses, gently amplifying the light of distant galaxies and giving astronomers a clearer view of the universe's earliest eras. When photons travel through these regions, they remain steady, even as space itself curves beneath them. They follow the shortest path through curved space-time, always moving forward, always maintaining their calm rhythm. This harmony between light and gravity creates a quiet balance in the cosmos, as though the universe is carefully guiding each photon along a graceful route that unfolds naturally. Even in the early universe, before stars and galaxies formed, light played a central role in shaping everything that would come later. After the Big Bang, the universe was hot, dense, and filled with energetic particles. Light could not travel freely because it was constantly scattered by charged particles in this primordial soup. Then, about 380,000 years after the universe began, the temperature cooled enough for atoms to form. Suddenly, light could move without constant obstruction. This moment released the cosmic microwave background, the oldest light in existence, which has been drifting through space ever since, carrying the faint imprint of the universe's infancy. The fact that we can detect this ancient glow today is a testament to light's endurance. For nearly 14 billion years, these photons have traveled without interruption, expanding and stretching with the universe. They now arrive as soft microwaves, filling the sky with a gentle, uniform brightness that offers a glimpse into the earliest moments of cosmic history. This background radiation is like a quiet hum, a subtle reminder of the universe's beginnings, preserved through the calm persistence of light's journey. Light also plays a role in connecting the smallest scales of physics with the largest. At the quantum level, light behaves both as a wave and a particle, a dual nature that reflects the delicate balance of reality. Photons have no mass, yet they carry energy and momentum. They can be created in atomic transitions, annihilated in collisions, or emitted as a result of nuclear processes within stars. Despite these interactions, the moment light enters a vacuum, it resumes its constant speed, as though guided by an unspoken rule that applies everywhere in the cosmos. The way light interacts with matter helps us understand the composition of distant stars. When atoms absorb or emit light, they leave distinctive patterns in the spectrum, tiny signatures that reveal temperature, composition, and motion. Astronomers study these subtle imprints to learn about objects they will never be able to touch. These spectral lines act like fingerprints carried across space by light, allowing us to explore the universe through the gentle clues it provides. Even the concept of time is deeply connected to light. In Einstein's Relativity, the speed of light defines the relationship between time and space. Clocks moving at different speeds or in different gravitational fields tick at different rates, all in accordance with the constant speed of light. This creates a universe where time is not rigid, but flexible, bending softly around motion and mass. Light serves as a reference point, a quiet standard against which the flow of time adjusts itself. For objects moving close to the speed of light, time slows down significantly. This effect is not just theoretical. It has been observed in particle accelerators, where fast-moving particles live longer than they would at rest. If a person could travel at a significant fraction of light speed, decades might pass for observers on Earth, while only months pass for the traveler. This time dilation is a gentle reminder that our experience of time is rooted in our own motion, and that the universe offers many different perspectives on the passage of moments. As we move farther into the details of light's behavior, it becomes clear that its constancy creates a sense of order underlying all cosmic processes. Stars shine because light carries energy outward from their cores. Galaxies glow because countless stars release photons that drift through space. Even the dark regions between galaxies are illuminated faintly by the combined glow of distant structures, their light blending into a soft haze. Through all of this, light maintains its pace, never wavering, never changing. It behaves with the same calm consistency in the violent heart of a star as it does in the quiet emptiness of intergalactic space. In understanding this, we find a sense of peace, a reminder that the universe, for all its complexity, is guided by simple and steady principles that remain unchanged across time. As you continue to drift through these thoughts, imagine the quiet motion of light as it glides across the cosmos. Feel its steadiness, its patience, its calm persistence. In its movement, the universe reveals itself gently, offering a soft, quiet reminder of the beauty woven into every corner of existence. As we drift deeper into the nature of light, its role in shaping the temperature of the universe becomes another quiet thread woven into the cosmic tapestry. Light carries energy outward from stars, gently warming the surfaces of planets and illuminating the cold expanses between them. In the early universe, before any stars had formed, light existed as a soft, uniform glow that filled all of space. Over billions of years, this glow stretched and cooled, leaving behind the faint microwave background that still surrounds us today. Its presence is subtle, yet it provides a calming reminder that even the universe began with light. Stars, too, owe their brightness to the movement of light. Deep within their cores, nuclear reactions create enormous amounts of energy. This energy slowly makes its way outward, bouncing from particle to particle before finally emerging as light. Once freed, it travels across space at its constant speed, carrying with it a small fraction of the star's warmth. Each ray of starlight you see has been on a long journey, shaped by both the internal processes of the star and the steady rules that govern light's motion. Some stars emit light so powerful that it travels immense distances, illuminating regions far beyond their immediate surroundings. Others glow softly, adding gentle contributions to the collective light that fills the galaxy. Regardless of a star's size or brightness, the light it releases moves outward in smooth, expanding spheres, touching everything in its path with the same quiet persistence. When this starlight reaches planets, it becomes the foundation for life as we know it. On Earth, sunlight drives photosynthesis, warms the oceans, and shapes the climate. Even though the sun is an ordinary star, its light has guided the evolution of countless forms of life for billions of years. And yet, the process remains calm. Light does not force itself upon the world. It simply arrives, traveling the same way it does everywhere else in the cosmos. The way light interacts with planetary atmospheres adds another layer of quiet beauty to its behavior. When light enters Earth's atmosphere, it scatters in a way that fills the sky with blue during the day and deepens into orange and red at dawn and dusk. These colors are the result of a gentle sorting process, where shorter wavelengths scatter more easily and longer wavelengths pass through more smoothly. This interplay between light and air creates familiar, soothing scenes. Sunsets, sunbeams, glimmering reflections, each one an expression of light following its natural path. On other planets, the same process can produce entirely different skies. Mars, with its thin atmosphere and dust-filled winds, glows with soft reddish tones, while sunsets often appear blue as the fine dust scatters sunlight in unique ways. The gas giants display hues of gold, turquoise, and deep violet as light filters through layered clouds of methane and ammonia. Even without standing on these worlds, imagining their skies invites a sense of wonder, as though light offers quiet glimpses into distant places. In the vacuum of space, where light travels without obstruction, photons can journey for billions of years without losing energy, unless the universe itself stretches beneath them. As space expands, the wavelengths of light stretch as well, shifting toward gentler tones. This process creates the redshift astronomers observe in distant galaxies, a soft indicator of how the universe grows over time. The farther away a galaxy is, the more its light has been stretched, revealing its distance through the subtle language of color. Some of the most distant galaxies are now visible only because their light has been magnified by clusters of mass between them and Earth. These clusters bend and focus the light, creating arcs and patterns that appear like shimmering brushstrokes across the sky. Even though the original photons may have traveled calmly for billions of years, the gravitational lenses they pass through offer us clearer, sharper views, as if the universe is gently amplifying the whisper of its past. Light also plays a role in the formation of stars and planets. In dense clouds of gas and dust, young stars begin to form as gravity pulls matter together. These protostars emit faint light, which gradually warms and shapes the surrounding cloud. As the cloud collapses further, light struggles to escape, bouncing and scattering within the dense material. Over time, as the star grows brighter and the cloud thins, light finally breaks free, illuminating the region like a soft dawn. This process marks the birth of a star, a moment defined by the release of radiant energy into the surrounding space. Planetary systems form within these illuminated clouds, guided by the gentle pressure of starlight. Tiny particles of dust collide and group together, gradually forming larger bodies. Radiation from the central star helps shape the structure of the growing system, pushing lighter particles outward and allowing heavier ones to drift inward. These slow, quiet processes continue over millions of years, with light acting as a steady influence on the formation of worlds. Even in the darkest areas of space, where stars are sparse and galaxies distant, light remains present in subtle ways. Some of this light comes from individual photons emitted by lonely stars. Some comes from the combined glow of billions of galaxies, blending into a faint background. And some comes from processes that occur in the intergalactic medium itself, where particles occasionally release small bursts of energy. All of this contributes to a soft, diffuse brightness that fills even the emptiest regions of the cosmos. As we imagine these distant places, it becomes easier to appreciate how light serves as a quiet companion throughout the universe. It marks the passage of time, reveals the shapes of galaxies, and carries the warmth of stars across unimaginable distances. Every corner of the cosmos is touched by light in some form, whether brightly or faintly, directly or indirectly. The gentle constancy of light's speed ties all these phenomena together, It allows the universe to reveal itself gradually, giving us glimpses of its structure in a way that feels calm and orderly. Through its movement, the universe speaks in soft tones, not rushed, not overwhelming, but steady, patient, and timeless. As you let your mind drift through these ideas, imagine a single beam of light continuing its journey across space. It moves in silence, untouched by time, gliding through the darkness with quiet certainty. In its path, the universe unfolds gently, offering its secrets not in sudden flashes, but in slow, deliberate whispers that invite reflection and rest. As we continue to drift through the nature of light, its connection to the passage of time becomes even more intriguing. The way light behaves sets the boundaries for how fast information can move, and because of this, time itself flows differently depending on how close something is to the speed of light. This relationship forms a quiet foundation for the universe, one that links motion, energy, and time into a single, gentle harmony. Imagine two clocks separated by vast distance, each ticking softly in a different corner of the universe. If one of these clocks begins to move at an incredible speed, close to the speed of light, its ticking will gradually slow compared to the other. This slowing doesn't come from mechanical strain or any physical limitation. Instead, time itself stretches, adjusting to the motion of the clock in a smooth, natural way. Even though the effect is subtle at everyday speeds, it becomes unmistakable as speeds approach that of light. Time dilation, as this phenomenon is called, is one of the universe's soft reminders that reality bends gracefully around light's constant pace. Particles called muons offer a calm demonstration of this effect. These particles form high in Earth's atmosphere and decay quickly. So quickly, in fact, that they should vanish long before reaching the ground. Yet many of them survive the journey because they are moving near the speed of light. For them, time passes slowly, giving them the opportunity to continue drifting downward. Their quiet persistence is a small but elegant example of how the structure of time gently reshapes itself under the influence of light speed. This relationship also means that light acts as a universal limit on how events unfold. Information cannot travel faster than light, which prevents cause and effect from becoming tangled or chaotic. Instead, events follow one another in a soft, orderly sequence, maintaining consistency across the cosmos. This built-in patience ensures that the universe remains stable, even across vast stretches of time and distance. Light speed isn't a barrier so much as it is a natural rhythm, the quiet pace at which the universe shares information. The idea of simultaneity, whether two events happen at the same time, also depends on light. For observers moving differently, the timing of events can shift gently, like reflections rippling on the surface of water. What appears simultaneous from one viewpoint may not be from another. This doesn't create confusion. Instead, it reveals the flexibility of time. Rather than being a rigid structure, time becomes soft and elastic, adapting to motion in a way that feels both surprising and deeply harmonious. Light also plays a role in linking energy and mass. According to Einstein's famous equation, E equals mc squared. Energy and matter are connected through the speed of light squared. a number so large that it reveals how even small amounts of matter contain immense potential energy. This relationship explains why stars shine, why nuclear reactions occur, and why the universe contains such vast reservoirs of power. Yet the equation itself remains gentle in spirit, showing that mass and energy are simply different forms of the same underlying substance, connected through the quiet constancy of light. In everyday life, the deep connection between mass, energy, and light unfolds in subtle ways. When atoms release energy, they emit photons, small packets of light that drift outward, carrying information about the processes that created them. These photons reveal temperatures, chemical compositions, and movement through their patterns of color and intensity. Light becomes a messenger once again, sharing the quiet details of the microscopic world with anyone able to listen. Even the way objects appear to move is shaped by light. When something approaches the speed of light, its length in the direction of motion appears to contract from certain viewpoints. This length contraction is not a physical squeezing, but a natural consequence of how space and time adjust to maintain the constancy of light speed. The universe rearranges its geometry with gentle precision, ensuring that nothing accelerates beyond the pace set by light. Because light defines the structure of relativity, it shapes the boundaries of what is possible in the universe. No object with mass can reach or exceed the speed of light, because doing so would require infinite energy. As speeds increase, the energy needed to accelerate an object grows dramatically, rising without limit as it approaches light speed. This quiet restriction keeps the cosmos stable, preventing runaway motions and preserving the soft order of cause and effect. The idea that nothing can outrun light has inspired many reflections on the nature of space travel. Science fiction often imagines spacecraft jumping instantly across the galaxy, but the universe itself moves at a gentler pace. Light becomes a guide to what is achievable, shaping realistic dreams of exploration. Even so, the distances are so vast that they invite calm contemplation rather than urgency. Traveling to the nearest star at a fraction of light speed would take years, filling the journey with long stretches of quiet reflection as the vessel drifts through the darkness. Yet even at these cosmic speeds, the universe remains serene. Space is mostly empty, offering smooth paths for motion without resistance. If a ship could glide through this emptiness at great speed, the stars would shift slowly in the distance, their light reaching the travelers with a timeless quality. Time inside the ship would pass differently than on Earth, but the difference would feel natural, like the gentle stretching of a quiet moment. The soft consistency of light speed also creates the concept of a light cone, the region of space-time that an event can influence or be influenced by. Everything within this cone is connected through the movement of light, while everything outside it remains out of reach until enough time has passed. This structure creates a calm, expanding sphere of possibility around every event, shaped by the quiet motion of light through space-time. As you imagine these ideas, let the softness of the universe's structure bring a sense of ease. Light moves through space with a grace that shapes time, space, and energy, linking them all together in a gentle harmony. Its speed is not an obstacle, but a guide, helping the universe unfold in smooth, predictable ways. And in understanding this, we find a calmness that mirrors the quiet persistence of light itself, steady, timeless, and beautifully constant. As we continue this quiet exploration of light, its influence on the structure of the cosmos becomes even more apparent. Light doesn't only illuminate the universe, it helps shape the way galaxies form, evolve, and interact. During the earliest stages of cosmic history, when the first stars ignited, their light began to carve away the dense fog of hydrogen that filled the young universe. This process, known as reionization, unfolded slowly and softly over hundreds of millions of years, gradually making space transparent and allowing light to travel freely between the growing clusters of stars. As stars gathered into galaxies, their combined light created gentle pockets of warmth within the cold expanse. The radiance from billions of stars blended together, forming the soft glow we see today in the spirals and ellipses scattered across the night sky. Even the faintest galaxies, barely visible and drifting at the edge of the observable universe, contribute their quiet luminescence to the cosmic backdrop. Each photon they send out begins a long and peaceful journey, passing through the dark with unwavering calm. Light also plays a role in regulating the temperature of galaxies. When stars form in dense regions of gas, their light warms the surrounding material, influencing the pace at which new stars can emerge. This gentle heating slows the collapse of gas clouds, creating a natural balance that prevents galaxies from forming stars too quickly. Over time, this balance helps galaxies maintain their structure, shaping their slow, graceful evolution over billions of years. In some galaxies, intense bursts of star formation release tremendous amounts of light, flooding the surrounding regions with radiant energy. These starburst galaxies glow brightly, producing clouds of ionized gas and vast regions lit by young, hot stars. Even in these energetic environments, light maintains its smooth and constant motion, drifting outward in expanding waves that reveal the hidden structures of the cosmos. The brightness of these galaxies becomes a kind of soft beacon in the universe, guiding astronomers to places where stars are being born at remarkable rates. In contrast, elliptical galaxies, older, quieter, and more diffuse, emit a softer light. Their stars are cooler and older, producing gentle reddish tones rather than the brilliant blues of young star clusters. These galaxies have settled into a calm, steady glow, illuminated by stars that have reached long, peaceful stages of their lives. Their light travels outward with the same unwavering speed as all other light, carrying with it the sense of ancient stability that defines these venerable systems. From entire galaxies down to the smallest grains of cosmic dust, light weaves itself through every scale of the universe. Dust particles, though tiny, play an important role in shaping the light we observe. They absorb and re-emit light, often transforming energetic ultraviolet photons into gentle infrared warmth. These processes fill galaxies with a soft, glowing haze, especially in regions where stars are forming. The infrared light produced in these regions moves at the same calm pace as all other light, offering a glimpse into the hidden workings of cosmic nurseries. Some of the most fascinating interactions between light and matter occur in nebulae, vast clouds of gas and dust illuminated by nearby stars. When ionized gas emits light, it creates the glowing colors of emission nebulae, forming serene scenes of pinks, blues, and greens. These colors arise from specific wavelengths of light released by atoms recovering electrons after being energized. The glow of a nebula is not a chaotic mix of colors, but a delicate interplay of photons produced by processes that unfold slowly and predictably. Reflection nebulae, on the other hand, shine because they scatter starlight. When blue light reflects off fine grains of dust, it creates a soft, ethereal glow that blends with the darkness around it. These regions appear as gentle patches of brightness, shaped not by the heat of stars, but by the calm redirection of their light. In these peaceful zones, light drifts softly, bouncing from particle to particle as it illuminates the surroundings with a quiet brilliance. Dark nebulae offer a different kind of beauty, absorbing light so effectively that they appear as silhouettes against the brighter regions of space. These dense clouds of gas and dust block the starlight behind them, creating soft outlines that reveal their shapes through contrast rather than glow. Even though these nebulae do not shine themselves, the light they obscure moves around them, following the same quiet rules that govern all of space. These dark regions serve as gentle reminders that light not only reveals, but also defines the absence of illumination. As galaxies drift through space, they sometimes interact, creating tides of light and matter that stretch across the darkness. When galaxies collide, their stars rarely touch, but their light blends and swirls together, forming long, delicate streams. These tidal tails, illuminated by the combined glow of countless stars, drift outward like soft brushstrokes across the canvas of space. The collisions unfold slowly over hundreds of millions of years, with light carrying the story of their movement across the cosmos. Even the large-scale structure of the universe, the cosmic web of filaments, clusters, and voids, becomes visible to us only because of the way light travels through it. The brightest clusters of galaxies outline the densest regions, while the dark voids remain softly unlit. As light travels along these immense pathways, it reveals the underlying architecture of the cosmos, offering a serene view of the universe's grand design. Through all these processes, from the formation of stars to the collision of galaxies, light maintains its constant speed and gentle nature. It threads together events separated by billions of years, carrying information from the distant past to the present moment. Its steady motion brings order to the cosmos, allowing us to glimpse the structure and evolution of everything that exists. As you reflect on these vast phenomena, imagine the quiet glow of galaxies drifting across space like distant lanterns. Each one sends out light that travels patiently, crossing unimaginable distances to reach us. The universe may be immense and complex, but light moves through it with calm certainty, revealing its beauty in steady, peaceful whispers. As we drift even deeper into the quiet behaviors of light, its role in revealing the motion of distant objects becomes another gentle thread woven through the cosmos. When a star or galaxy moves toward us, its light shifts slightly toward shorter, bluer wavelengths. When it drifts away, its light stretches toward red. This shift, though subtle, offers a soft way to understand the movement of the universe. Through the calm changes in color, astronomers can listen to the rhythm of cosmic motion, quiet signals carried by light across vast distances. These shifts are not abrupt or dramatic. They unfold slowly, reflecting the gentle speeds at which galaxies drift apart. The universe expands without hurry, and light patiently records this expansion in the stretching of its waves. The more distant a galaxy is, the more its light has shifted toward red by the time it reaches us, creating a soft spectrum of movement that reveals the structure of space itself. In this way, light becomes a peaceful indicator of the universe's growth, whispering softly about the passage of cosmic time. Closer to home, the Doppler effect shapes the light from stars within our own galaxy. As stars orbit the center of the Milky Way, their light subtly shifts, showing their speed and direction. Some drift toward us, others drift away, all following the quiet gravitational paths that keep the galaxy in balance. These gentle shifts help astronomers map the motion of stars, uncovering the calm rotations and serene spirals that form our galactic home. Light also reveals the presence of planets around distant stars. When a planet passes in front of its star, even briefly, the star's light dims by a tiny amount. This dimming, though incredibly small, becomes a soft signal that a planet is there, drifting through its orbit. In some systems, astronomers can detect faint reflections of starlight off a planet's atmosphere, or the subtle pull that the planet exerts on the star. These interactions unfold quietly, offering glimpses into worlds we may never see directly. The way light interacts with planetary atmospheres can provide clues to their composition. When starlight passes through an atmosphere, certain wavelengths are absorbed by molecules within it. This absorption creates delicate patterns in the spectrum, revealing whether the atmosphere contains water vapor, carbon dioxide, or other gases. These patterns are like soft fingerprints, allowing us to study distant worlds from across the galaxy. Through light, the universe gently shares the secrets of these distant atmospheres, one photon at a time. Even within our own solar system, light plays a central role in exploration. Space probes rely on beams of light, radio waves, which are a form of electromagnetic radiation, to communicate with Earth. These signals travel across millions or even billions of kilometers, arriving with a slight delay that reflects the vast distances involved. When messages from spacecraft reach Earth, they carry the calm echoes of journeys through deep space. Each transmission is a small reminder of how light connects us to the quiet reaches of the solar system. The time it takes for these signals to arrive creates a natural rhythm for exploring the cosmos. When a probe near Mars sends a message, it might take anywhere from 3 to 20 minutes for the signal to reach Earth, depending on the distance between the planets. This delay means that everything unfolds slowly and steadily, at a pace set by light itself. Controllers must wait patiently for updates, trusting the quiet consistency of the universe's speed limit. In this way, light defines the tempo of space exploration, guiding our interactions with distant machines through soft, measured intervals. The behavior of light also influences the temperature and climate of planets. When light reaches a world, some of it is absorbed and some is reflected. The balance between absorption and reflection creates a planet's albedo, a property that affects how warm or cool the planet becomes. High albedo, dull worlds like icy moons or snow-covered planets reflect most of the light back into space, remaining cold and serene. Low albedo worlds, like dark rocky planets, absorb more light, warming gently as they bask in the glow of their stars. These interactions unfold slowly over time, creating stable environments shaped by the calm flow of light. Some planets experience dramatic variations in light, such as those locked in synchronous rotation. One side of the planet faces the star permanently, bathed in continuous sunlight, while the other side remains in everlasting night. The boundary between these hemispheres becomes a soft twilight zone, where light and shadow meet in a permanent, gentle balance. The temperatures here are often stable and mild, shaped by the constant but subdued interplay of illumination and darkness. Light also reveals the structure of planetary rings, casting shadows and highlights that define their delicate patterns. When sunlight strikes the rings of Saturn, it reflects off countless particles of ice and rock, creating shimmering bands that drift smoothly across the planet's silhouette. From afar, these rings appear tranquil, but up close, the interplay of light and shadow becomes a soft dance of illumination, shaping the graceful appearance of one of the solar system's most iconic features. In more distant systems, light helps uncover new and unusual planets. Some worlds reflect very little light, appearing almost invisibly dark. Others reflect so much light that they shine brightly, even from afar. The differences in reflection, color, and brightness tell stories about their surfaces, atmospheres, and temperatures. Through these subtle cues, light gently reveals the diversity of worlds scattered throughout the galaxy. Even the faint glow of zodiacal light, caused by sunlight reflecting off tiny dust particles within our solar system, adds to the quiet beauty of the night sky. This soft, triangular glow appears near the horizon after sunset or before sunrise, a gentle reminder of the dust left behind from countless comets and asteroids. The light it reflects is delicate and serene, blending with the darkness in a way that feels timeless and peaceful. As light travels through the cosmos, carrying information about motion, composition, and temperature, it maintains its steady pace. Each photon follows its path without hesitation, linking distant regions of space in a quiet network of illumination. Through these gentle interactions, light becomes the universe's storyteller, sharing its observations softly and patiently, without urgency or interruption. As you reflect on these ideas, imagine light drifting through the darkness, revealing worlds, tracing motion, and illuminating the quiet patterns of space. Its presence is constant and dependable, moving with a grace that shapes everything we see and understand. In its journey, the universe unfolds gradually, offering its secrets in calm, soothing whispers that guide us into deeper rest. As light continues its quiet journey across the cosmos, it not only reveals the motion of distant worlds, but also shapes the soft boundaries between darkness and illumination. Every place touched by light gains a subtle connection to the stars, while every place it has yet to reach remains wrapped in calm shadow. This contrast is not sharp or abrupt. It unfolds gently, like a slow tide moving across the surface of a vast and peaceful ocean. When light encounters matter, it interacts in ways that reveal the texture and structure of the universe. Some materials absorb light, converting its energy into warmth that spreads softly through their surfaces. Others reflect it, creating glimmers and glints that travel outward, carrying quiet reminders of what they touched. Still others scatter light in many directions, producing halos, glows, and soft veils of illumination. These interactions are delicate and graceful, shaping the colors and tones that give each place its unique character. Light has a way of traveling across the universe that feels almost unreal when you think about it quietly. A single beam that leaves a distant star simply keeps going, brushing past dust, weaving through invisible magnetic fields, slipping between drifting atoms, and it never slows, never stops, never questions its own direction. It just continues forward, steady and silent, until it eventually reaches the lens of a telescope or the back of someone's eye. In a way, every time you look into the night sky, you're meeting something that has been traveling toward you for longer than human history has existed, and it finally arrived at the exact moment you decided to glance upward. There's something soothing about imagining light moving through those enormous distances, completely unbothered by the empty space around it. Even in regions where galaxies thin out and the void becomes almost absolute, light continues on, untouched. It doesn't drift or meander. It stays perfectly straight, like a promise being kept. And in that endless stillness between worlds, you can picture a lone beam passing through the dark, faintly shimmering, as if the universe itself is gently carrying it. Across millions of years, that same beam might pass ancient stars that have long since faded away, or glide near the outskirts of nebulae where new stars are being born. It moves through time just as easily as it moves through space. Whole civilizations could rise and fall while a ray of starlight is still on its way to us. And when it finally arrives, it carries no mark of all that history. It's just light, unchanged, quiet, and patient. It's also comforting to realize that the warmth we feel from the sun is older than it seems. The photons that heat your skin on a calm afternoon weren't created at the sun's surface. They were formed deep inside its core, in places where the pressure is so intense that hydrogen atoms fuse together. But after their creation, those photons don't rush outward immediately. They wander inside the sun, bouncing around in a chaotic, glowing maze for thousands or even hundreds of thousands of years. By the time they escape and travel to Earth, the world is in a completely different place than when their journey began. Every ray of sunlight touching you carries a story older than humanity itself, and it whispers that story without words, through warmth alone. And yet, when that ancient light finally reaches Earth, it transforms in ways that feel familiar and human. A sunrise unfolds slowly, layering soft peach and pale blue until the sky glows like it's breathing. During those early moments, The sun's light is scattered by the atmosphere, bending and tinting itself in colors that feel impossibly gentle. Even on mornings when you don't see the sunrise directly, that subtle shift in brightness carries a sense of newness, as if the world is waking up for you. Light becomes something emotional, something that shapes mood and memory without you ever having to think about it. At night, starlight seems even softer. It fades into a kind of cosmic hush, where the brightness doesn't demand attention but simply exists, quietly outlining the sky. Some stars flicker not because they are unsteady, but because Earth's atmosphere slightly bends their light as it passes through. That tiny shimmer makes them feel alive, like distant lanterns swaying in a slow, invisible breeze. You can picture each one as a small point of stability in a universe that's always moving. Even the light reflected off the moon carries its own gentle rhythm. Moonlight isn't actually its own light at all. It's sunlight, dulled and softened by lunar dust, then cast back toward Earth with a kind of pale, calming grace. It's why moonlit nights feel different from nights lit by lamps or screens. Moonlight has traveled far, changed shape, and returned to us with some of its sharpness removed. It feels softened by distance itself. When you think about how much light interacts with, the simplicity of its behavior becomes soothing. Light doesn't worry about obstacles. When it meets something solid, it either reflects, bends, or gets absorbed. But it never resists any of those outcomes. It simply adapts. It reflects off oceans in glittering ribbons that stretch toward the horizon. It bends through glass to create miniature rainbows along the edges of a window. It sinks into the surface of warm pavement and becomes heat. In every case, light responds instantly, effortlessly. It never fights the world around it. It just becomes whatever the moment requires. Sometimes the most relaxing thing to imagine is how light behaves when it meets tiny particles of air. The reason the sky looks blue is because shorter wavelengths of sunlight are scattered in all directions by the molecules in our atmosphere. That scattering creates the illusion of a dome of color above us. On a hazy day, those same particles scatter the sunlight even more gently, softening the sky until it feels almost velvety. Light changes its expression based on what stands in its way, and a single shift in humidity or temperature can make the same sky look completely different, like a mood changing quietly from one moment to the next. Light also stretches across huge cosmic distances without aging. As the universe expands, long traveling light gets pulled outward with it, stretching into longer wavelengths. A ray that began its journey as bright visible light might eventually become infrared, and then microwave radiation. Those ancient microwaves fill the entire universe with a faint, uniform glow. The cosmic microwave background is the oldest light in existence, a soft afterimage of the universe's earliest moments. Even though you can't see it with your eyes, it surrounds everything, like a quiet reminder that the cosmos once glowed entirely. There's something soothing in imagining a universe where even the oldest memories still gently shine. The cosmic background isn't loud or noticeable. It's a subtle whisper of brightness that fills every space, no matter how empty. If you could close your eyes and feel it, the universe might feel warm, not because of heat, but because of the idea that light never truly disappears. it only changes form. Closer to home, light also interacts with water in ways that feel almost meditative. When sunlight meets the surface of the ocean, it reflects in scattered patches, each one shifting softly as the waves move. Some of that light enters the water instead, sinking downward in fading blues. In shallow water, the light makes patterns on the seafloor, rippling grids that sway slowly like a silent dance. But deeper down, sunlight disappears layer by layer until only the faintest trace remains. Imagining that slow descent from brightness to twilight to deep restful darkness feels like a natural metaphor for drifting off to sleep. Even in the human body, light plays a quiet, steady role. Your circadian rhythm, your internal sleep cycle, is guided by the rise and fall of light throughout the day. When sunlight reaches your eyes in the morning, it signals your brain that it's time to wake up. As that light fades in the evening, your body naturally begins to wind down. It's a gentle partnership between biology and the universe, a reminder that you're not separate from the world outside, but part of a long, ancient relationship between life and light. Imagine, too, how light looks when it passes through something delicate, like a candle flame in a dark room. The flame bends the light upward, creating a halo around itself. That halo flickers softly, responding to the smallest movements of air. It's one of the few places where you can watch light behave almost like a living thing, restless, warm, and somehow comforting. Candlelight doesn't illuminate everything. It creates small pockets of warmth surrounded by shadow. That contrast makes the light feel safer, more intimate, like a place you can gently rest your attention. Light can also echo in ways you might not expect. When it reflects off multiple surfaces in a room, tiny echoes of brightness blend together to form the ambient light you barely notice. That ambient glow is what makes a room feel calm or cozy, even when you're not consciously paying attention. It's the quiet presence of illumination, diffused and softened until it becomes more of a feeling than a sight. In the right conditions, that kind of light can make you breathe more slowly or settle more deeply into a comfortable place. Whenever starlight hits dust floating in space, the dust scatters it outward, creating faint, luminous clouds called reflection nebulae. These nebulae aren't bright on their own. They only glow because passing starlight brushes through them. The dust itself becomes a canvas for traveling photons, and the result is one of the universe's most serene sights. Nebulae look like soft watercolor paintings suspended in space, their edges blending quietly into the surrounding dark. It's easy to imagine drifting past them, floating weightlessly while their pale colors fade in and out around you. And if you picture the universe from far enough away, all these small pockets of light, stars, nebulae, galaxies, come together to form a kind of cosmic tapestry. From a distance, galaxies look like swirling clouds of brightness, each one containing billions of stars, and each of those stars sending light outward in all directions. It creates the sense that the universe isn't cold or empty at all, but gently illuminated from within, like embers glowing inside a vast, dark furnace. Even the idea of light having no mass can be strangely calming. Photons are weightless, yet they carry energy across unimaginable distances. They don't get tired. They don't drift off course. They don't lose themselves. They simply continue forward, unburdened by anything. Thinking about that can ease the mind, imagining something that never strains, never slows, never worries, just steady motion through open space. Sometimes, the most relaxing thing about light is that it always reveals something without ever changing what it reveals. It reflects the world quietly, without judgment. Light touches everything equally. The tallest mountains, the deepest valleys, the smallest grains of sand, the still surface of a lake, the wrinkles in an old book, or the gentle curve of a sleeping face. It transforms each surface into something softer, something more peaceful, simply by illuminating it. You can imagine light drifting through the curtains of a quiet room, outlining dust particles floating lazily through the air. Each tiny particle catches the beam for just a moment before drifting back into the dimness. That slow, drifting motion is the kind of natural rhythm that lulls the mind, making it easier to release tension. Even if the world outside is busy, a single sunbeam falling into a quiet space can create a pocket of calm. It's also peaceful to think about how light interacts with time, because it moves so quickly. Whenever you observe something far away, you aren't seeing it as it is now. You're seeing it as it once was. Light becomes a messenger from the past, carrying memories that the universe left behind. Looking at a distant galaxy is like opening a letter written millions of years ago, a message that has traveled across unimaginable distances to quietly arrive in your field of vision. The more you think about it, the more light starts to feel like the universe's way of communicating, not through words, but through gentle, continuous presence. Stars shine not because they want to be seen, but because shining is simply what they do. Light emanates from them with no urgency and no expectation, just steady brightness spreading outward forever. Even lightning, which seems violent, becomes calming when viewed from far away. A distant flash illuminates clouds for a moment, revealing their shapes before allowing darkness to settle back in. The thunder that follows arrives softened by distance, turning from a sharp crack into a low, rolling murmur. Light's ability to change character based on distance and context makes it one of the universe's most expressive forces. And even though light moves at the fastest possible speed, the effect it has on us is often the opposite of fast. It slows the mind. It softens edges. It makes moments feel longer, more expansive. Whether it's the faint glow of a nightlight, the gentle pulse of bioluminescent algae near a shoreline, or the sweeping arc of the Milky Way overhead, light creates space for quiet thought. When you imagine light traveling across the universe, through nebulae and past dormant stars, brushing gently against planets and drifting through cold interstellar clouds, it becomes more than just a physical phenomenon. It becomes a kind of cosmic lullaby, something ancient and ever-present that you're always connected to. And maybe that's why thinking about light feels so calming. It reminds you that even in the vastness of space, illumination is always there. Sometimes bright, sometimes faint, sometimes scattered so thinly that only delicate instruments can detect it. But it's there, moving forward without hesitation, filling the universe with quiet persistence. Light is, in many ways, the universe's gentlest constant. You can follow it with your imagination, letting it guide you across galaxies and through star clusters, drifting with it until your thoughts slow down and settle. And as you trace that path, you might notice your own breathing falling into a softer rhythm, as if matching the steady, endless journey of a single photon making its way through the cosmos. On Earth, the interplay of light and matter creates everyday wonders that often go unnoticed. The gentle shimmer of moonlight on water, the soft glow of morning sun through mist, the warm hues of a setting sky, all arise from the calm and predictable way light scatters, reflects, and refracts. These familiar scenes, though ordinary, echo the same cosmic processes that unfold across galaxies and nebulae. Light behaves with consistent elegance, whether illuminating a distant star cluster or drifting through the quiet air of a forest at dawn. When light passes through transparent materials, it bends gently, changing direction as it enters or exits. This refraction creates the soft rainbows that appear after storms, the sparkle of sunlight on glass, and the magnified images seen through lenses. The bending of light allows us to focus images, observe distant objects, and explore the microscopic world. Through these interactions, light becomes not only a messenger, but also a tool for understanding the fine details of reality. Even the colors we perceive depend on how light interacts with the surfaces it touches. A leaf appears green, not because it contains green light, but because it reflects that wavelength while absorbing others. A calm ocean reflects the sky, appearing blue when the sunlight above scatters through the atmosphere. The colors we experience are shaped by a delicate balance between light, matter, and the structure of our eyes. They arise from a quiet conversation between photons and the world around us. Beyond these everyday interactions, light reveals the hidden structures of matter at the smallest scales. When photons strike electrons, they can knock them into higher energy states, creating ripples of activity that change how atoms and molecules behave. These processes occur constantly within the matter that makes up planets, stars, and living beings. Even so, they unfold gently, guided by the natural rules that govern the behavior of light and energy. In the world of quantum mechanics, photons behave both as particles and waves, embodying the dual nature that defines the smallest building blocks of the universe. This duality may seem strange, yet it reflects a quiet versatility that allows light to adapt to the needs of each situation. As a wave, it carries information through space. As a particle, it interacts directly with matter, transferring energy in small, precise amounts. This balance helps maintain the delicate structure of atoms and the stability of the world we know. At larger scales, light reveals the boundaries of magnetic and electric fields, making visible the invisible forces that shape matter. Auroras, for example, form when charged particles collide with atoms in Earth's atmosphere, releasing light in smooth curtains of green, red, and violet. These displays drift across polar skies like gentle waves of illumination, produced by interactions that occur quietly at the edge of space. The aurora is a reminder that even energetic processes can create scenes of profound calm and beauty when light is involved. In deep space, magnetic fields surrounding stars and planets shape the movement of charged particles, guiding them along curved paths that occasionally release photons. These interactions produce soft glows in nebulae along star-forming regions and around the edges of galaxies that reveal the presence of forces otherwise hidden. Light becomes the gentle outline that traces the structure of these fields, offering astronomers a peaceful way to understand the dynamics of distant regions. Light also plays a role in the cooling of stars. As stars emit light, they gradually release energy into space, allowing their core temperatures to change over millions or billions of years. This slow process determines how stars age, how they evolve, and how they transition into new phases of existence. When a star eventually leaves the main stage of its life, it may shed its outer layers in a peaceful drift, forming a planetary nebula illuminated by the soft glow of ultraviolet light from its core. The resulting patterns appear as delicate rings, shells, or filigrees, shaped by the flow of light through the expanding gas. Even black holes, which allow no light to escape from within their event horizons, rely on light to reveal their presence. The matter falling toward a black hole heats up as it spirals inward, releasing intense radiation that illuminates the surrounding region. These glowing disks of gas, known as accretion disks, create a soft halo that outlines the darkness at the center. The sharp contrast between the bright disk and the shadowed core is not harsh or violent. Instead, it resembles a quiet boundary between illumination and absence, shaped entirely by the behavior of light at extreme velocities. As we move deeper into the vastness of the cosmos, the presence of light remains constant, threading through galaxies, nebula, star clusters, and the empty reaches between them. It carries the memory of ancient events, records the motion of celestial bodies, and illuminates the architecture of space-time. Through its steady pace and gentle interactions, it gives shape to a universe that might otherwise remain hidden in darkness. When you imagine light traveling across billions of years, touching worlds, gliding past stars, and weaving through galaxies, it becomes clear that its journey is one of profound calm. There is no sense of urgency, no struggle or tension, only smooth, patient motion through the silent depths of space. Each photon moves forward with quiet purpose, reflecting a universe guided by steady principles and timeless rhythms. As you continue to drift with these thoughts, allow the steady presence of light to guide your mind into deeper rest. Its path is smooth, its speed unwavering, and its story written gently across the fabric of the cosmos. In understanding the calm nature of light, we find a peaceful connection to the universe itself, a reminder that even in the vastness of space, there is order, harmony, and a quiet beauty that invites us to relax and breathe. When we think of light, we often imagine something swift and energetic, a flash, a spark, a burst. But across the vast quiet of space, its movement feels almost gentle, like a soft ripple traveling across an endless, darkened ocean. The speed itself never changes, but the experience of that journey stretches into something long and peaceful. As light moves outward, it becomes a kind of silent messenger from the past. Every ray that reaches your eyes tonight began its journey long before this moment, carrying with it a memory of where it came from. Some of that light may have left a distant star before the first humans ever walked the Earth. Some may have traveled across galaxies whose shapes have slowly shifted over millions of years. And yet, here it is now, arriving quietly, without urgency, without effort. This gentle travel through time is one of the calmest truths about light. It connects different eras of the universe in a steady, unbroken line. The moment the light reaches you is not the moment it was created. It is simply the moment you meet it. Every star we see is sending us a message from a time long gone, a peaceful reminder that the universe moves at its own pace, independent of our busy days and restless nights. Imagine a star that sits 100 light years away. The soft glow that reaches Earth tonight began its journey before your grandparents were born. Imagine another star 1,000 light years away, its faint light beginning its trip before the rise of ancient civilizations. And then imagine a galaxy 1,000,000 light years distant, its shimmering light starting its voyage before humans even existed, crossing through emptiness with the same calm determination it has always had. There is something soothing about this idea, that the universe is full of gentle signals from long ago, arriving slowly and quietly, like soft echoes drifting across time. And each beam of light continues forward, never hurried, never delayed, moving with perfect consistency, as though the cosmos itself breathes in a slow and steady rhythm. Sometimes, when astronomers look up at objects countless light years away, they are not just studying space. They are looking directly into history. They see the universe as it once was, not as it is now. That quiet, steady quality of light allows us to gaze backward through layers of time, uncovering stories written in the faint glow of distant stars. And just as those ancient beams travel calmly across the darkness, you can imagine your thoughts drifting in the same way, soft, unhurried, and weightless. Each idea floats by without pressure, the way starlight moves across unimaginable distances. You don't need to hold on to anything, just let the gentle sense of time and distance create a feeling of spaciousness, like there's more room inside your mind to breathe and simply be. The universe has been sending these quiet messages for billions of years, and it will continue to do so long after tonight. Light never rushes. It simply travels. It simply arrives, and it simply shines. One of the quietest, most comforting ideas in astronomy is the way light becomes a natural ruler of the universe. Instead of meters or miles, astronomers use light years. The distance light travels in 1 year, as a way to describe the space between stars. But despite sounding enormous, a light year feels almost peaceful when you think of it not as speed, but as a steady, constant rhythm, like a soft metronome marking the passage of time. A light year is nearly 6 trillion miles, yet the concept itself feels gentle. It simply represents the distance that light glides through the darkness, while the universe continues its calm, slow unfolding. There is no rush in that measurement. There is no urgency. is just the quiet amount of space that light naturally covers over the course of a year. One smooth, unbroken journey. When astronomers say a star is 10 light years away, they're telling you that the light reaching your eyes tonight began its journey 10 years ago, moving through the quiet, empty spaces between stars. And when they speak of a galaxy millions of light years away, they're describing light that has traveled for millions of peaceful, uninterrupted years before finally arriving here. This way of measuring distance creates a kind of soft connection between time and space. The farther away something is, the older the light that reaches us. The universe doesn't hide its past. It sends it to us gently, wrapped in these long, delicate beams that have drifted for ages. Imagine looking up at a star that appears small and faint. That star might be hundreds of light years away, meaning you're seeing it as it was centuries ago. Long before trains, long before electricity, long before the modern world existed. You are looking at a tiny message from a distant moment, preserved in light that never hurried, never stopped, and never strayed from its steady pace. There is something incredibly calming about this. The idea that light is patient enough to carry the past forward, one soft moment at a time. That the universe is filled with these quiet reminders of how vast time truly is, and yet how gently it passes when seen from a cosmic perspective. Even closer objects, like the moon, reveal this soothing delay. Moonlight takes a little over 1 second to reach Earth. That means the light you see when you look at a full moon left its surface just a moment ago. Sunlight, even brighter and more familiar, takes about 8 minutes to arrive. Every sunrise is really 8 minutes old by the time it touches your skin. A small reminder that even the brightest light moves with calm consistency. These subtle delays create a beautiful sense of depth in the night sky. Every star, every planet, every galaxy exists both in space and in time. And the universe lets us explore both simply by observing the light that drifts to us. As you think about these distances, you might feel a sense of spaciousness inside yourself as well, like the timeline of your own thoughts lengthens and softens. There's no need to rush through anything. Just like light traveling across the cosmos, your mind can move gently, steadily, and without pressure, finding its own natural pace. The night sky becomes a quiet map of moments, stitched together by the slow, patient journey of light, a measuring stick drawn from the calmest movement in the universe. As we drift deeper into the quiet story of light, there is another calming truth to explore. One that ties light not just to distance or time, but to the very shape of the universe itself. It's a gentle idea, not rushed or complicated, and it reminds us how softly everything in the cosmos is connected. Light doesn't just move through space. It reveals the way space is shaped. Imagine the universe as a vast, flexible fabric. Not rigid, not fixed, but smooth and flowing, like a soft blanket stretched out beneath you. This fabric bends and curves ever so slightly around stars, planets, and galaxies, forming slow, graceful arcs that are too subtle for the eye to notice on its own. But light feels these curves. It glides along them effortlessly, following the natural contours of the universe without hesitation. When light passes near something massive, a star, a cluster of galaxies, or even a black hole. Its path bends gently, like a leaf floating around a slow ripple in a pond. This bending is called gravitational lensing, but the experience of it is much more peaceful than the name suggests. It's simply light, choosing the easiest path through the quiet curves of space. From our point of view, these bends create soft distortions in the images we see. A distant galaxy might appear stretched or doubled, not because it's changing, but because the light it sends travels through a cosmic valley shaped by gravity. Space doesn't twist the light abruptly. It guides it with a smooth, natural flow, letting the universe itself act like a gentle lens. And in this subtle bending, we learn something peaceful. Light is honest. It always follows the simplest route, revealing the contours of space without resistance or urgency. Its path is a slow, graceful response to the quiet shapes carved into the universe over billions of years. Even when space is almost perfectly flat, as it is in many regions, light continues forward with the same calm determination. Straight paths, curved paths, it doesn't matter. Light adapts, it moves, it glides. Astronomers use these delicate motions to understand the invisible structures around us. By observing how light shifts or stretches, they can trace the presence of things we cannot see. Clouds of dark matter, distant clusters of galaxies, or the soft curvature of the universe itself. Light becomes a messenger not just of time, but of shape, form, and hidden patterns. It's comforting to think that the universe has these quiet signatures, and that something as delicate as a beam of light is able to read them effortlessly. Nothing forces it forward, nothing rushes it along. It simply responds to the landscape of space, the way water follows the contours of a riverbed. As you imagine these gentle paths, you might find a sense of ease settling in, as though your own thoughts can follow the same slow curves, drifting where they naturally want to go without judgment or expectation. Just like light moving through the cosmos, your mind can take the shape of whatever calm landscape it finds tonight. The universe has many ways of telling its story, but few are as soft, steady, and reassuring as the way light reveals its shape. And in that quiet revelation, there is a sense of peace, a reminder that even across impossible distances, the cosmos moves with patience, softness, and harmony. Light doesn't just travel through space. It quietly records everything it touches along the way. Every beam carries with it a soft imprint of its journey, a memory of the stars it passed, the dust it slipped through, and the gentle motions of the universe unfolding around it. And because light travels with such steady patience, these imprints become a calm, reliable way for us to understand how the cosmos has changed over time. When light leaves a star, it carries a signature of that star's temperature, color, and age. As it moves outward, crossing the quiet gaps between stars, tiny interactions with cosmic dust soften its glow, tinting it with delicate hues. When it reaches Earth, astronomers can gently spread that light into a spectrum, a rainbow stretched into thin, peaceful lines, and each line tells part of the story of its long journey. These spectral lines read like whispers from the past, They reveal whether a star is moving toward us or drifting away. They show us how hot or cool it once was. They let us see the traces of elements created in ancient stellar furnaces. And they show us how the universe itself is expanding. Light has always been a quiet traveler, moving through the universe with a kind of steady certainty that feels peaceful just to imagine. Even long before telescopes or science or language, light was already carrying the stories of distant places. It moved between galaxies, slipped past drifting clouds of dust, and continued onward without ever needing to hurry. It was patient in ways that feel comforting, like a reminder that the universe has never rushed a single moment of its existence. If you picture a beam of light leaving a star, you can imagine it beginning its journey in a place full of heat and brightness. But the farther it travels, the softer the universe becomes. The star behind it stays loud and fiery, but the space ahead grows deep and quiet. That tiny beam moves through this stillness in complete calm, untouched by wind, untouched by sound, untouched by anything that could disturb its simple path forward. It's almost like watching a feather drift across a room where nothing else moves. As this light travels away from its home, the spaces it passes through begin to shape it. It might brush against a thin wisp of cosmic dust and scatter into soft, hazy colors. It might pass the faint glow of a nebula and carry a new tint with it, like watercolor bleeding gently into paper. It might slip through a region of almost perfect emptiness, where the silence is so complete that even the concept of time feels slower. Yet even through all of this, the light continues with unwavering ease. There's something comforting in imagining the way a single ray stretches across billions of kilometers without ever straining. Light doesn't fight for progress. It doesn't push or struggle or force its way through the universe. It simply moves, smooth, straight, steady, across the quiet fabric of space. And the farther it travels, the more peaceful his journey becomes. Sometimes, that same beam will pass near a massive star or a silent planet, curving just slightly under the pull of gravity. This gentle bending is called gravitational lensing, and even that effect feels almost soothing. It's not a sharp detour, it's a slow arc, like turning a page with the softest touch. The universe guides the light around obstacles in a smooth, graceful motion, and then lets it continue on its way, as if nothing ever disturbed it. If you imagine this process repeating across trillions of beams, all drifting calmly through different parts of the cosmos, the universe begins to feel like an enormous ocean of quiet motion. Light is like the soft ripple on the surface, subtle, continuous, impossible to interrupt. And even though the distances are overwhelming, the behavior of light remains gentle. It carries no weight. It leaves no wake. It touches everything without changing shape. Eventually, some of these ancient rays reach areas filled with dust or gas clouds that glow in muted pastels, blues, pinks, purples. The scattered light inside those clouds creates shapes that look like soft brushstrokes painted across the sky. They aren't bright or sharp. They're diffuse, blurred, and calming, like something fading slowly into dream. Even telescopes capture them with that same softness, as if the universe prefers its artwork to be tranquil rather than bold. And through all this, it's strange but comforting to realize that the light we see now may have left its home before humans existed. or before Earth had trees, or before oceans had formed, or even before our sun was born. These rays have been drifting peacefully through space for longer than we can imagine, carrying quiet impressions of where they came from. When this light finally reaches us, it arrives without any sense of the journey it took. It doesn't feel tired or aged. It simply appears. A soft glow, a gentle color, a faint shimmer at the edge of a photograph. There's no urgency in it, no trace of the vast distances behind it, only the calm presence of something that has traveled in perfect stillness across the universe. As you imagine these beams drifting for ages through empty space, it becomes easier to feel your own thoughts slowing down. Just as light moves without tension, your mind can move without pressure. You can settle into that same quiet rhythm, letting each idea pass gently into the next, with no need to judge or control it. The universe is never in a hurry, and you don't need to be either. In this peaceful, drifting motion of light, there is a kind of reassurance that even in a universe so large and ancient, the softest things can still carry meaning across extraordinary distances. Light teaches us that moving slowly, moving calmly, moving without strain is enough. It always has been. And now, as we move toward one of the universe's most delicate phenomena, we can let this sense of calm expand. Because even when light changes, even when it stretches across space, even when its color shifts, the transition is gentle. When astronomers observe distant galaxies, the light arriving here appears subtly stretched, its wavelength lengthened into deeper, calmer colors. This stretch is called redshift, and is one of the most peaceful truths in all of cosmology. The universe is growing slowly, quietly, and gently over time. Space itself is opening, creating more room for stars and galaxies to drift apart in a calm cosmic expansion. We aren't watching this expansion in real time. We feel it through the light that left its home millions or billions of years ago, before drifting patiently across space until it met our telescopes. This soft stretching of ancient light lets us understand the universe the way it once was, not through loud explosions or dramatic motion, but through gentle, consistent patterns written into the glow of distant galaxies. Light reveals not chaos, but continuity, not urgency, but the slow unfolding of time. Even the faintest beams, the ones that left their sources when Earth was still forming, drift into our detectors with quiet clarity. They carry information from an age before oceans, before mountains, before life. And yet, they arrive unchanged in their purpose, to illuminate what has happened, softly, one detail at a time. As you imagine these delicate signals traveling across unimaginable distances, you might feel a sense of calm widening inside you. Just as the universe expands, gently and steadily, your thoughts can expand into a more peaceful space as well. There is no need to hold on to anything, no need to rush. Everything unfolds in its own time. The way light moves across the cosmos, smooth, patient, and effortless. Light is not just illumination. It is a quiet archive, preserving soft impressions of how the universe grows and changes. And as it reaches us, It brings with it a reminder that even the grandest forces in existence can move in slow, peaceful rhythms. As we reach the end of this gentle journey, you might notice a soft stillness settling over you, the same kind of calm that exists in the quiet spaces between stars. Light has carried us through some of the universe's most peaceful ideas tonight, moving at its steady, patient pace, revealing stories written across billions of years. And just like those ancient beams drifting through space, you can allow your thoughts to float wherever they want to go now, slow, unhurried, and without pressure. Nothing needs your attention. Nothing needs to be solved. There is only the quiet unfolding of this moment. The universe is vast, but it is also calm. Its rhythms are slow, its distances gentle, its stories soft and patient. And as you rest here, you're a part of that same easy rhythm, breathing in, breathing out, letting the night settle around you like a blanket. Thank you for spending this time with Science for Sleep. Whether you drift off now or simply enjoy a few moments of peace, know that this calm is always here for you, steady as starlight, quiet as the empty spaces between galaxies. Rest well, drift gently, and let the peaceful glow of the universe guide you into sleep.